Oh, good day! Today, I'm gonna show to you the Laplace transform of e raised to negative 80 sine bt. So first, you need to take the integration of e raised to negative st times e raised to negative 80 sine bt. The limits are from 0 to infinity. Next is to simplify this equation. So you can simplify it by the integration of e raised to the quantity negative s minus a times t sine bt dt. Limits are from 0 to infinity. There's a dt here. So you can solve this equation using integration by parts. So you will need to find u. U is equals to sine bt. The derivative of that is equal to b cosine bt dt. And your dv is equal to this equation, negative e raised to the quantity negative s minus a times t dt, and the integration of that is negative 1 over s plus a times e raised to the quantity negative s minus a times t. Substituting it to this equation, uv minus integration of v du. So your u is equal to sine bt and your v is equal to negative 1 over s plus a times e raised to the quantity negative s minus a times t, and the limits are from 0 to infinity. Substituting the limit early will avoid confusion later. So minus this, your integration of v is equal to negative 1 over s plus a, your du is equals to b cosine times e raised to the quantity negative s minus a t cosine bt dt. So substituting the limits, this will become t negative sine b times infinity over s plus a times e raised to quantity negative s minus a times infinity. Negative times negative, because this is minus, so this will become plus, sine b times 0 over s plus a times e raised to the quantity negative s minus a times 0. So e raised to a negative very large number is equals to 0. So this will cancel. And sine 0 is equals to 0. So 0 over any number, this will become 0. Cancel. Next is find the integration by parts of this equation. So put the b, negative b over s plus a outside. So this will become positive b over s plus a, and the integration of e raised to the quantity negative s minus a times t cosine bt dt. Limits are from 0 to infinity. You need to find u in this equation. So u is equals to cosine bt, and the derivative of that is equals to negative d sine bt dt. Your dv is equal to e raised to the quantity negative s minus a times t dt, and the integration of that is, this is negative 1 over s plus a times e raised to the quantity negative s minus a times t. So substituting this to the formula uv minus the integration of v du, this will become, don't forget the b over s plus a here, quantity, u cosine bt over negative s plus a times e raised to the quantity negative s minus a times t. Limits are from 0 to infinity, minus the integration of v is negative 1 over s plus a times e raised to the quantity negative s minus a times t, and your du is equals to negative b sine bt dt. Substituting the limit, this will become, bring down this, negative cosine times infinity, b times infinity over s plus a times e raised to the quantity negative s minus a times infinity, minus, so this will become plus, cosine b times 0 over s plus a times e raised to the quantity negative s minus a times 0, minus b over s plus a. So as you can see in this equation, this is the same as this equation, which is equal to Laplace of e raised to negative at sine bt. So let Laplace of e raised to negative at sine bt is equal to y. So substitute it by y. So e raised to negative very large number here is equals to 0. So cancel this. And cosine 0 is equal to 1. E raised to 0 is equal to 1. So 1 over s plus a times 1 is equal to 1 over s plus a times b over s plus a. So this will become b over s plus a quantity squared minus, multiply this by this, so negative b squared over quantity s plus a plus quantity squared times y here. And don't forget to put y here, because as let Laplace is equal to y, this, so there's a Laplace here, so this will become y. And then putting this number into the left, transposing, this will become positive. So y plus b squared over quantity s plus a squared y is equal to b over quantity s plus a raised to 2. And then there's a 1 here, so you can add this because it has the same variable. So 1 plus b squared over quantity s plus a raised to 2. So this will become s plus a squared plus b squared over quantity s plus a raised to 2 is equal to b over s plus a raised to 2. Then cross multiply this. Oh, there's a y here. Cross multiply this. This will become y is equal to b over s plus a squared plus b squared. So let y is equals to Laplace, so substitute Laplace of e raised to negative at sine bt is equal to b over quantity s plus a squared plus b squared, and this is the final answer. And that's how it is done.